First,
finished up.
this is actually day 2 of our cyber threat panels. And I kind of want to bring you up to speed a little bit. We got some great opportunities here for you to not only learn but also to enjoy a chat, what we call fireside chat between Dan Geer and Barbara Endicott-Poposky. I want to kind of give you a little bit of background though from where we were yesterday. Yesterday we set up a panel and we had individual presentations. We talked about the threat actors, the threat landscapes. Barbara went into a little bit more depth as to just exactly what that really means and what some of the steps we need to take going forward. And then we had intermixed in there Remy Baumgarten, who is our tech head, and he went into a little bit of depth with regards to the vulnerabilities of some mobile devices. Namely, he talked a little bit about the iPhone, which probably has more security in it than most, and then cascaded down to the Android, which I carry on my hip all the time, which is far more vulnerable than most type of mobile devices. And it's the iOS. We also learned a little bit about jailbreaking and some of the terminology there and how, in fact, it affects. So it was a real good opportunity yesterday. Those who were there, hopefully you learned some things and hope you walked away with a little bit more knowledge and at least a smattering. It's a basically high-level overview, and so consequently as such, there was a lot of information passed, but hopefully you took away at least some knowledge and ideas and understanding of where we're heading for. Today we have this panel right here where first of all it's a fireside chat between Dan and Barbara, and then we're going to have a panel where you can ask some questions and go a little bit more depth. And then this afternoon, under direction of Paul Kurtz, well actually Dick Clark's going to speak at noon for lunch, and then Paul Kurtz, who's back here with us today, is going to lead the cyber panel. So in this we have a steady flow of cyber. You probably heard it this morning, it was introduced. The fact is that we're kind of cracking the barrier, so to speak. We have folks here that represent the cybersecurity events within their industry and the cybersecurity activities within the industry, so we're real pleased to have you here today too. So we're going to start out this morning. I want to introduce, first of all, is Dan Geer. Dan is the Chief Information Officer for Incotel. He's also a farmer, and so true, and he owns a large farm, and so we were talking today, but Dan is an MIT grad, and he is very, very well steeped within the cybersecurity world. I'll get back to that in just a second. Facilitator of this would be Barbara Endicott-Poposky. Barbara has 1 foot in industry and 1 foot in academia. 1 foot in industry is with Global Business Analysis. That's my firm. I'm the CEO of the company, by the way, and former fighter pilot. So in essence, go ahead and we'll go from there. At any rate, Barbara is the Senior Manager and Director for Technology for their GBA and Cybersecurity, and also is the Director for the Center of Information Assurance and Cybersecurity for the University of Washington. PhD, and Barbara we were talking yesterday, there's 160 of the Centers for Excellence for Cybersecurity throughout the United States, of which University of Washington is in the top 10, and it's because of Barbara. And so the work that she has done and also the work that she has done worldwide is absolutely amazing. And so we're well pleased to have her here with us. So in essence, I'm going to turn the time over to her. She's going to talk a bit about Dan and then go ahead and progress from there. Thank you very much.
Thank you, Dave. It's a pleasure to be here. I see a lot of faces from yesterday. How many of you did sit through yesterday's briefing? Quite a few. Can I ask the question I asked yesterday then? How many of you folks are engineers? Many of you. How many of you are in management, decision-making capacities? You could be both, okay? So we had a fairly high-level discussion yesterday talking about a real generalized overview of cybersecurity and some common sense ways of looking at it. And we ended on a note that there is an opportunity as we integrate computers into our products and services in this industry. There's an opportunity to get ahead of the curve and consciously integrate secure engineering concepts from a cyber perspective. And so the model that we gave to the audience was the power grid industry that had a group of a consortium, almost like an ISAC kind of a group, that developed guidelines for smart grid, which I think has been helpful. It remains to be seen how everything gets implemented, but certainly the motivation was to get ahead of the curve. The internet got off to a commercial start without the cybersecurity folks, and we've been catching up ever since. And so the smart grid people looked at this and said, you know, we're going to do it differently this time. Having come back from Black Hat and DEF CON, there certainly was an emphasis in the demonstrations this year about attacks on critical infrastructure to a greater degree than I've ever seen. Certainly people who've been working in cybersecurity have been concerned about infrastructure, and we think that the bad guys are as well. It is a huge privilege for me to be working with Dan Geer. I have to tell you, and I think I told you this by email, Dan, but you were an inspiration to me. I won't tell you, yeah, you were. At Stake was an organization in the Northwest. I followed some of the work they were doing and the thinking that was coming out of there. And against my better judgment, I had interrupted my industry career, my consulting practice, to go back for a PhD while my daughter was still going to college. And I found a home in some of the thinking that Dan and one of his colleagues, John Tan, were developing, an idea of forensic readiness, once again anticipating getting systems ready to yield admissible advice. So Dan was at the very beginning of my inspiration for the direction that I've taken my academic career. So I have to thank you, Dan. You've been an icon. Dan has been involved with cybersecurity before there was any such thing. Like many people in the field today who've been practicing for a while, they come from other disciplines. It's interesting that Dan did come from biostatistics. And of course, today that's even more important as we move to these large integrated health exchanges. I would
Correct.
Imagine the things that you were looking at are even more timely. Dan also is responsible for leading the development of Kerberos. How many in this room know what Kerberos is or manage Kerberos systems? It's a crypto system.
Authentication.
And it is the most widely used program in the world.
Could well be.
And I'll ask you a little bit about how that came about, Dan. How did the development come about?
Well, thank you for the introduction. I hope that part's over.
No, I have some more things to say about you.
Thank you all for inviting me. Kerberos was a implementation of, there was a paper in 1978 in the Communications, the ACM, by Schroeder and Needham on a protocol for authentication. How do you, over an open network, prove that I'm me, or how can I prove to you that I'm me, and vice versa? And the protocol had been analyzed and shown to be correct, which is hard enough, but can be done. And MIT was busy building a large, I worked at MIT at the time, was busy later, but at the time I want to speak of here, was busy building a large distributed computing environment when that was sort of a new thing. Something called Project Athena, which may or may not ring any bells, but is irrelevant. In that case, the Dean of Engineering had preempted all of his department heads and said, nobody's going to negotiate with a computer manufacturer for free stuff but me. And so he went to Ken Olson. You may never have heard this, but I think you'll find it amusing. He went to Ken Olson, who ran Digital Equipment, who was an MIT alum, and said, we'd like some computers and some money and some people. Then he went to IBM and said, you don't want this little upstart place to show you up now, to embarrass you now, you ought to match them. And he went back and forth 2 or 3 times, and we ended up with rather a lot of computers and a lot of money and a lot of people at a time when that was rare. And so to one extent, you should say if we didn't turn out anything useful, we should all be shot at sunrise, because 1985, being given $100 million worth of equipment, you really ought to, you really ought to do something. But of course, that was MIT, where the phrase "no user serviceable parts inside" is typically an invitation to open up whatever it is, whether it's a hairdryer or a safe or the dean's office or what have you. And we need an authentication system, so we turned to Needham and Schroeder protocol. Schroeder had been a doctoral student of Jerry Salza, who was the academic in charge of Athena. And we did that, and the important part about that, I will say, is that after a great deal of argument with the technology licensing people and so forth, it was decided to give it away. And there were plenty of people at MIT who wanted to, in fact, sell the technology, license it, the usual intellectual property drill. We decided we'd get more out of it if we gave it away, and in fact we gave all of Athena away, and in fact it changed everything because the X-Window system came from there, the idea of using a name service for something other than looking up a host address came from there, the idea that eventually became instant messaging came from there, the Kerberos authentication system came from there, and so forth and so forth. And by giving it away, it created a standard, and so those of you who are in a position to have the debate of would we be better off extracting income and licensing this, or would we be better off having everybody standardized to something we wrote? I can give you at least one working example that standardizing to something you wrote has its positive impacts, because in short order, all of academia and a large part of industry was using this, and it ended up being a standard. Now, it is still a standard. All of these things are still standards. They just have morphed, which is fine, But the authentication system part was an acknowledgement that in a network, particularly one which was only freshly available for commercial use. You may remember when the internet was not available for commercial use, but it was only freshly available for commercial use. The idea that everybody who you might talk to was someone you already knew was about to pass away. And of course, we're way beyond that now. But internet design, which I still think is spectacular success, did assume that the parties who were communicating with each other were in some sense known. And the challenge, of course, today is that's far from it. I think the most important decision ever made about internet design from a security point of view was the end-to-end principle. The idea that the network is transport and transport alone. It is not a policy engine. And instead, if you and I, I'll pick on you, if you and I want to communicate, the security protocol we might use is our negotiation, that we decide upon it in the process of some automated negotiation, that it isn't policy inherent in the network. And that is what made the internet spread possible. On the other hand, it is what, as a side effect, produces the very problems that we now want to talk about. But the end-to-end principle, if you want to go back and read it, it was Reed, Clark, and Salzer paper, underlies all of this. And in a sense, the Kerberos authentication system is how I got started, because I was working for Salzer, of the three of them. And we had an environment where we had a lot of smart kids, and if we tell them not to futz with things, the first thing they do is futz with it. So after a while, you learn how to use that, by the way. You say, this is impregnable, and that gets you testers for free. After a while, you do the judo thing, is all I'm saying. The thing to remember is where, in some sense, where all this came from. And where it all came from was the idea that security for communications will vary by the communicating parties and ought to be negotiated between them and not be a feature of the network. And there are many calls to the contrary now. We should have a new internet that is secure. That's difficult without other side effects. And at the very least, if we decide to do something like that, we're going to have to think about side effects in a more structured way than we used to. That's more of an answer than you wanted, but that's how we got to where we are.
So you are now focused on security metrics. Somehow you were indicating that your professor enjoyed keeping you so long. There was some question about whether or not you'd ever graduate.
Anybody who's ever been a grad student realizes at some point you have to tell your committee that you're done. They're not going to tell you you're done. You have to tell them you're done. And
they get publications out of you guys.
Yeah, or free labor, or
right.
Would you pick up my kid, or you name it. I'm a statistician by training. So, as you said earlier, everybody who has been in security for any substantial time, everybody my age in some sense, came at it from something else because there was no training per se. That's very different now. UW, amongst others, has very well-developed training programs, but that was not always the case. So people my age came from something else. I happen to come from biostatistics. But it gives me a worldview that, for example, I think of things in terms of disease models and efficiency of transmission, and acquired immunity, and the idea that the reason you measure something is not for science but for decision making. Science is wonderful, don't get me wrong, but the reason that in public health you'll never, except under the rarest of circumstances, actually eliminate a disease. The smallpox example being a spectacular worldwide success that took 50 years. But the idea that I need to measure something that allows me to say, should I do more of this or less? Trivial example. No street cop will ever know how much methamphetamine is for sale, but they can tell the price. If the price is rising, perhaps what they're doing is effective. If the price is falling, whatever they're doing is not effective because the price wouldn't otherwise be falling. That avoids having to measure something you can't measure. It does, however, by measuring a trend, allow you to make decisions. And so I think security metrics, this is for me sort of like motherhood and apple pie. For me, security metrics is in support of decision making about the state of security and not a scientific goal in and of itself. I've got nothing against people who want to do theorem proving or something like that, but for me that is a public health point of view. A public health point of view is talking about large scale general effects and not about, is Dan going to get sick? It's a question of, is the number of people with H5N1 going up or going down? And that's how I view the problem.
Dan has brought up an interesting point that this industry, cybersecurity, this field, grew up out of other disciplines.
Yeah.
And it's been interesting to me to watch how cybersecurity, that it's information assurance, sometimes used interchangeably, how those terms and how the field has evolved and how it is currently defined.
Indeed.
The IEEE in 2001, after a great deal of debate with people I work with in DHS, NSA, declared it a field. And I participated in conferences where people have been trying to define it and agree on it. And there hasn't really been any come to terms that is mutually acceptable to everybody that's playing.
I'm going to interrupt you and say right there that one of the things that I think we have to accept as opposed to continue to work on is that we all have slightly different definitions of every component.
That's exactly true. And so I was going to ask you, how do you define cybersecurity? How do you scope it? You've already indicated to the audience that you see it through the lens of the discipline you studied, which has been very valuable.
I see it through that lens in the sense that, what any statistician would tell you is all data has bias. The question is, can you correct for it? And so I was trying to tell you what my bias was,
Sure,
in the hopes that you could correct for it. But my definition of security, well, it's sort of evolved over time, and I don't claim that I will now have this engraved on my tombstone in advance, but I think the definition I like at the moment, and I don't mean to be flip about this, but the one I like at the moment is a state of security is the absence of surprises that you can't mitigate. The absence of unmitigatable surprise. In other words, expect there always to be surprises. The question is, can you mitigate them? We're in California, so I'll use California SB 1386, the first of the data breach laws. It said that, it doesn't say, dear, who can I pick on? J.C. Penney? Hannaford? You're forbidden to lose credit cards. That's insane. What it does say is that if you do, you must tell the people that you might have lost their credit cards. You must buy them a certain amount of credit watch service. You must come clean about this. You must be prompt. You must have independent third-party verification that your analysis was correct, and so forth. In other words, it says, we know that bad things will happen, but here's what you do when they do. And so the absence of unmitigatable surprise is, I think, as good a working definition of the state of security, given that, amongst other things, we don't have a definition.
So if you were to speak to, as you are now, to an audience with people who are in aerospace and aviation, looking through that lens, how would you reconcile your definition?
Well, I know less about aviation than anyone else in the room, so let me just stipulate that and get on with it. But it seems to me that everyone here knows, again, and probably more than I do, about redundancy. About having redundant systems where if this one fails, there's no impact to overall performance because you have fallbacks of various sorts. Having designed systems that had redundancy in them, I understand that part. I just don't necessarily understand it in the context of airplanes, but I understand that part. Although I do know one thing, which is that if you've got, say, a situation where 4 out of 5 must be working or 3 out of 5 must be working, if one of them fails, it's good to discover that it has failed and not have it be a silent failure, because now your margin of safety has gone down. And the next one that fails, your margin of safety has gone down. Still nothing bad has happened. The next one that fails, discover that you have no margin of safety because you've already burned it up because you didn't notice that you'd gone from 5 to 4 to 3 to now you're in trouble. And redundancy is a great thing, and I think that in my knowledge of aviation is there's a great deal of emphasis on redundancy. Perhaps if you want to call space a version of aviation, you don't get to fix the things that are out there quite so easily as maybe you do on land. That redundancy idea, though, is not sufficient in and of itself. What I'd like to suggest is that from a design point of view, that if I had to pick a star to steer by, I'll never get to Polaris, but I know it's north, and if I need to steer, I can steer by that star, though I will never reach it, okay? In that sense, I think the top-level idea behind security design is no silent failure. That if it fails, you know it. You may not have ever read, but although I recommend it, the Verizon Data Breach Investigations Report. It comes out twice a year. Verizon has a big consulting service. Needless to say, the people who hire them are people who've been recently embarrassed and have the money to hire Verizon and so forth. So it's a little bit of a biased sample. Back to my point about all data has bias. The question is, can you correct for it? But these are legitimate firms, and there are a lot of them. And Verizon takes all of their consulting practice and rolls it together so that no one is exposed by talking about it. So that by rolling it all together, they obscure who's who. And the feature of that I want to mention is that 80% of the data losses are discovered by unrelated third parties. Now, that's a counterexample to no silent failure. And why? Because, of course, if I take your data, you still have it. So how would you know? And the answer is, well, under current levels of ordinary practice, as measured by the consulting experience of Verizon, the answer is, by and large, you don't. Myself and a colleague, we run, who's at a bank in New York that refuses to let me name where he is, it's one of those things, run a thing called the Index of Cybersecurity. The people who are respondents to this are CISOs and people like that, people with operational responsibility for security. They're speaking for themselves and not for their firm, so it doesn't matter to us if there's 3 people at a certain firm. What we're looking for is experts. And we ask them the same questions every month, and so you can think of this as being just like the Consumer Confidence Index. Consumer Confidence Index asks basically the same questions every month, and every month it gives you a number at the end, which is a number. And the number is, in a sense, dimensionless, and what you're looking for is it up or down. Now, the consumer confidence, of course, is range-bound between 0 and 100, whereas, say, for example, the Dow Jones is not range-bound. It can go arbitrarily high, it can't go below 0, but nevertheless, it's not range-bound. And so we copy the Consumer Confidence Index and the Purchasing Managers Index a little bit in both cases. Why? Because those are boring, and we want boring. Boring is good. We don't want someone to say that the results you get are an artifact of your collection method. So we copy other people's collection methods. Why do I say all that? Because the questions that we ask are to gauge, in the last month, has malware pressure gotten better, gotten worse, gotten a lot better, gotten a lot worse, stayed the same? These are called, if this means anything to you, a 5-point Likert scale. This is standard for survey research. It has a useful advantage, which is it doesn't matter whether my definition of malware and yours are the same, because you're self-referential. Has it gotten better or worse given your definition? So as long as you don't have a definition that wanders all over, each month you have a different personal definition of malware, I've got a problem. But assuming you don't, this is good data. Every month we also ask a special question. The special question for, I believe it was October, was, have you ever discovered a data breach involving another firm? We got 55% yes, confirmed, 10% yes, but unconfirmed. That's 65%. We exclude law enforcement from our catchment for this index. So we got 65% excluding law enforcement. Verizon gets 80%. I would say that's confirmatory. So the statement about silent failure is, I think, now got two independent methods of confirming that silent failure is common, at least with respect to data breaches. I would suggest that data breaches are important. They may not be the most important thing for aviation because operational integrity may well be more important, but data breaches are important, and they are, of course, fairly common for better or worse, they're fairly common. What would that tell you? It would tell you that, at least with respect to data handling, protection of confidentiality is a situation where we are not aware of when we lose it. I suspect, going to your smart grid or electronic health records, I suspect in those cases data confidentiality is not the pinnacle goal, but data integrity is. Because I may not care, if I'm in a hospital, which practitioner knows what my liver function looks like, but I may well care that no one has modified it.
Correct.
And then given me a lethal dose of something.
Correct.
So
I worry about allergies. I have a Tony Soprano novel in mind where the bad guy flips the bit and you no longer have an allergy on your records and it's
Sure.
over.
Sure, and it would be a bit, by the way. It would be a bit. So anyway, my point is that that in a different domain than intellectual property or than personal privacy issues, it may well not be the confidentiality, but I just had this working example of, on the one hand, the regular reports from Verizon, and on the other hand, the one little attempt at verification that we did, that we have silent failure. And I said all that long-winded answer to underscore that I think designing for knowing when you have failed is probably more important at the limit than designing for no failures, because there's an asymptote. There's a cost curve that, the next 10% costs twice as much as the previous 10%, and the one after that is worse. So at some point you say, well, we're going to stop trying to prevent. I'm not telling anything out of school here. Goldman Sachs in New York is, I think, the acknowledged leader in cybersecurity in finance. Not always, but they've taken it seriously for a long time. And they recently, 2 years ago, made their CISO a partner, which at Goldman is a big deal. And so the event of a mark in time, you have your timeline, you make a little mark, say, at this point it became clear that this was important. At Goldman, that would be they made their CISO a partner. Phil Venables is his name. And it's been 2 or 3 years now, maybe a little more, 3 or 4, that they have made, in the choice for availability, which is slightly different choice here, but as you probably know, you can get 100% availability either by making failures impossible, that the time between failures goes to infinity, or you can make it availability 100% by making the time to recovery go to 0. So you can drive the mean time between failures to infinity, or you can drive the mean time to repair to 0. Either way, you get 100% availability. And for some time now, again, maybe 3 to 4 years, Goldman has been investing in driving the mean time to repair to 0, as opposed to further investments in making the mean time between failures go to infinity. In other words, you put a certain amount of effort into, this is not going to happen, and here's why. You start ticking off all the controls you've got. You might also say, there is a diminishing return at some point, at which you say, from now on, additional investment goes into making recovery instantaneous. Because after all, if something fails, if you got a trading application that fails at 3 seconds before 4 o'clock, you are, in a world of high frequency trading, you are way screwed. And so having an instantaneous recovery becomes far more important than can we prevent failures at 3 seconds to 4. But that's what I'm getting at, is there's a trade-off there, and the trade-off requires judgment. But it goes back to this no silent failure idea.
This is great. I think that those of you here that are engineers and appreciate measurement would find the data breach report valuable, and the reports that you put out as well, Dan. And I'd like to return to your comments about redundancy in aviation, because we do have an incredibly safe aviation industry, safer to fly than to drive a car.
I sleep on the planes. I don't sleep in the car.
That's right. Well, Google wants us to be able to do that.
You know, it's fabulous.
So we have an incredibly safe industry that has gotten safer. And I did work in the aviation industry, so I'm very aware of the value they place on safety and on engineering.
And you know something? I will compliment all of you. I have never seen an advertisement where, I'm just making this up. I've never seen an advertisement where Delta says our planes fall out of the sky less often than theirs. I've never seen that kind of advertisement. Everybody has a similar interest. That has not been true even in banks. That's not been true.
Correct. So the industry itself has been very conscious of safety, but there is a difference between safety and security. And so you've touched on a little bit. I was going to ask you if you might expand or...
Well, this comes back to definitions of words. I think safety has to do with when an event or a planned activity or whatever is all behind you, are you still here, in so many words? I mean, we need a definition of some sort. How about that? Security, I think, is more a measure of how hard is it for someone to call. Let me back up and say, the difference between cybersecurity and, for example, component failure, having the tip come off a rotor or something, is that cybersecurity breaches are, whatever it is, 99.44% on purpose by somebody who means ill. And it's not, stray alpha particles or bad luck or, a crack you didn't see on an X-ray. It's actually intentional. And that does change things. And I think it changes things more than any place else in the divergence between security and safety, to the extent there is a divergence. I think, by the way, the average person would not make much of a distinction here. But the fact that there are intentional opponents, I think, does change things, and change it a lot, because it says that the half-life measurement of a component that fails at random is something that can be experimentally determined. The half-life of something that fails because of sentient opponents is not. And in fact, I would suggest that what is the definition of a security product is something that it has sentient opponents. If you say that there are people who would like to make this fail, then I think you at least ought to adopt the rigor that comes with building a security product, even if you're not prepared to call it a security product in the vernacular.
Right.
But the presence of sentient opponents does change things compared to, again, pipe failures or, how high should the wall be between you and the ocean in case there's a landslide?
Sure.
That's a very different kind of thing, even though from a safety point of view, how high should the wall be between you and the ocean is critical. After all, we're busy demonstrating such things from time to time. But I think the cyber one is particularly dependent on what do you think the opponent structure is, how badly do they want this? In a sense, what you want to ask is, does anybody want this? On the one hand, you might say, here's what it costs to break the crypto on some algorithm, on some protocol. Does anyone want it broken badly enough that they would spend that amount of money, or that amount of time, or that amount of computing? Remembering, this is Adi Shamir, as in RSA, the A the S of RSA. He got the Turing Award, and in his lecture he said, "You must remember that crypto is rarely broken, mostly bypassed," and that's the distinction here.
Yes. So one of the things that happened in the context of your discussion about aviation and the difference between security and safety and its unusual characteristics of having redundancy built into the engineering, which isn't the case with everything.
It's not the case by and large, except for load balancing. It's not the case in commercial, for example, e-commerce at all. So
what happened last year was rather interesting, and I'm sure you read about it. There were a couple of white hat hackers that demonstrated theoretically taking over an airplane, and given people's understanding who are in the industry that this isn't so easily done. There are redundant systems. They don't really understand what an airplane
Sure.
does or how it was built. It gave a little bit of discredit to the notion that security was even relevant in the aviation industry because these guys don't know what they're talking about. And so,
Is that the worst you can do kind of reaction?
correct,
Yeah,
it's the
okay.
worst you can do. And I saw something similar, you mentioned load balancing. I saw a similar reaction in the power grid industry because the people who were waving their hands and crying out that power grid was vulnerable, it was connected to the internet or business systems could have access, truly didn't understand power engineering. And so they were somewhat discredited because they lacked the understanding of that discipline. So how would you comment on the relative vulnerability of the aviation industry or,
Nothing like a hard question.
well, I mean, given what I've just said,
Yeah. Well, correct me if I'm wrong. Failures that reach the level of being on the front page of the newspaper, we've come to the point where rarely are they a single failure, that there are a couple of compound failures.
correct.
Going back 10 years, the American Airlines, was it 587, the one that fell into Queens, which was partly a component failure and partly an operator error. Other ones like that, I don't read the blogs about, failure modes of this sort, but the idea that we've reached the point where a failure is rarely a single failure. The issue with cyber, I think, is that because we are expanding the reach of cyber as quickly as we are, and by that I mean attaching things to the internet, providing fly-by-wire, drive-by-wire, whatever it might be. Google's cars, no doubt, are outside right now. Because we're expanding that at the rate we are, the possibility of having a single point of failure, as opposed to with redundancy, you don't have a single point of failure, I think is the issue, although it's hard to get a handle on it because what are you going to measure? And again, I'm a measurement nut, so what are you going to measure? But redundancy says that we're here to prevent a single point of failure, in some general sense. In the hooking up of everything to the cyber world, we are not obeying that rule at all. We are creating single points of failure. I do not think that 8 years ago, the first Ohio power failure, the first energy power failure in Ohio, I don't think it was caused by a cyber failure. But my guess is that the alarm systems that they had at their various locations were frustrated in their ability to send alarms to the central control office because they had an ongoing infection of blaster at the time. And my guess is they had network congestion and it delayed the alarms. And since it appeared that they had perhaps a 3-minute window of opportunity to prevent the cascading failure, if you're in a network congestion, an otherwise irrelevant network congestion situation, that's an issue. So it's, again, an example of it wasn't one thing that failed, it was multiple ones. But the cyber arena, I think, produces single points of failure that we don't really anticipate. I will pick one completely unrelated to aviation, but it looks to me like we're going to have a maybe 10-year interval in which there's a considerable overlap between IPv4 and IPv6. My guess is that area of overlap is ill-studied and likely to produce what I know as an electrical engineer to call an impedance mismatch. In other words, places where odd effects may occur. What's an example? IPv6 provides multi-homing on a constant basis. You can have more than one network address at all times. My guess is that combined with the bring your own device trend, bring your own device to work trend, inadvertent bridging of networks is likely to ensue. And the inadvertent bridging will be between IPv4 networks attached to an IPv6 host that didn't realize it was doing multi-homing and has now produced bridging. Is that a problem? It's probably just a nuisance, but it's an example of a long-term situation where we don't know what to test for. We don't know how to do this. Bring your own device to work. I don't know whether the aviation industry hates this or loves it. What's a good example? GE Capital. What is the name of the gentleman? Beeson. Phil Beeson. Jim Beeson, the CISO of GE Capital, has for quite some time been the champion of bring your own device to work under the somewhat clever phrase of, I don't buy your shoes, why should I buy your computer? And on the other hand, our friends at the intelligence agencies still don't permit you to have a cell phone. And so there's, on the one hand, a principled kind of analysis that says cell phones in a top secret or higher environment are a no-no. And on the other hand, the idea that we are not going to capitalize the computing devices. Carpenters bring their own tools to work. Why shouldn't intellectual workers? There's such a broad spectrum there. How do you test that? And again, I'm a fanatic about testing, so forgive me for beating the same drum over and over again, but how do you test that? How do you say that, perhaps even under compliance rules, how do you say what compliance with that means? Because it changes so fast.
Yes.
It changes so fast. I know full well that in aviation, perhaps more than anything except maybe nuclear power, the cost of recertifying a change to a critical system is daunting. I'm well aware of that. What are you going to do about auto update in a world where recertification is daunting? And certainly all the commodity suppliers of computing and communications gear are moving toward auto update because they fear, on the one hand, liability from not having updated systems. I mean, I just did a piece on this. Approximately half of Microsoft's install base and approximately half of Apple's install base don't get security updates anymore because they've stopped supporting, in the case of Apple, 10.5 and below. With Microsoft, they're about to stop XP. Now, mind you, a large part of XP is in China. Nevertheless, what do you do when a wide, perhaps half of the world's computers don't get security updates anymore, on the one hand, and on the other hand, what do you do when both suppliers want to move to an auto update environment? What do you do with that in a situation where recertification is abundantly painful? I don't know the answer to that. Maybe you have to do your own. Maybe you have to say that we're not going to take the updates because we freeze the systems. But to do that, I'm almost certain that means that whatever systems you use, you have to cut them down to the bare minimum. The average stock market car mechanic's main job is to remove unneeded parts from the car. We do not need a back seat. It weighs us down. We do not need, and go on and on and on. We do not need a catalytic converter. This is NASCAR after all, and so forth and so forth, to remove the unneeded parts, because unneeded parts decrease function. Unneeded parts in a computer situation are, I don't use that function, so I will never notice if someone else is using it. How do you do that cut down? I don't know that this is science, but it's an art.
So you're really alluding to risk-based decision-making, which is what security ends up coming down to. It
has to
costs
be.
money, there are risks, but how do you get a handle on risks in an industry? How would you recommend an industry go forward and assess its situation given this brave new world that we're obviously going to enter, where everything is interconnected? How would you go about getting a handle on this issue?
I'm going to ask you a question in reverse. How did the airlines, not so much those of you who are builders, but the airlines decide that it was, at least some of them, decide it was time to permit Wi-Fi on the planes? There has to have been a decision process behind that besides just
Money.
the marketing advantage.
Money?
As in follow the money?
It's revenue. You're offering a feature that passengers want to be connected on a plane, and they have the ability to,
But you block Skype.
it's bandwidth issues.
It's a bandwidth issue.
Yeah.
Well, that's money.
Everybody's on Skype, the whole airplane bogs down, and nobody can get in.
Well, I'm just saying.
So, yeah.
But the reason I asked that question.
And your competitors are doing it.
Sure.
So now if one has go-go and another one wants go-go, and now they're looking, on international flights, having satellite communication and broadband so that you can do it internationally. It costs you more money to make that phone call or to get on the internet.
Oh, I have no doubt that you can recover the cost and more. I have no doubt about that. But was there a safety type debate on this?
There was safety, yes.
Other than turning it off at 10,000 feet?
But security was not always, and John can speak up, but
The security pieces are not necessarily front and center.
I see.
On what the airline would like, what else they would like besides the passengers to get, what type of information they want to get into the cockpit going through the same system is kind of like, no, you can't be doing that.
Well, you know, a long time ago, I did a consulting job for General Dynamics in Groton for what at the time was a new attack sub. And it had a requirement that I bet is just like that you'll find familiar, and that was the commanding officer and the executive officer had to be able to use the onboard networks at all times for all purposes because of you might be in a diminished operations situation. On the other hand, there were two networks, a tactical and a strategic network. The strategic network connected to the torpedoes and the missiles. The tactical network was the galley. When they pulled into port, they ordered potatoes over this.
We have the same segmentation.
And yet, the XO and the CO wanted to be able to connect to either network and operate the entire. And so the Venn diagram of overlap here for what would you want to have happen was a null set. And I'm not making fun of this because it all was logical at a sense. But I'm sure it's the same thing with what do you want to get in the cockpit versus.
Well, that's right, and the airplanes, this is just in Boeing, there's a air ring standard around the domains, around safety driven by the highest level domain. How do you control and operate the airplane? You know, the highest level, and then airplane information system, how is information getting to the pilots to be able to operate, updating the nav database and things like that.
But in that, correct me if I'm wrong, that would be integrity would be the high order bit as opposed to confidentiality.
That's correct. Because a lot of stuff, as information goes out, that comes in and off the airplane is not encrypted. But again, people need to understand the loss of that system, or the fact that people can penetrate or potentially get messages, is a failure of the communication. It's not a failure of the safety of the airplane, because that system is not critical necessarily to the operation. So if it happens, shut it down. You can still operate the airplane safely. It's not, it's not an overall system. So this is where risk is important. What is the risk of shutting down the reading lights or the coffee pot relative to corrupting the flight controls or the GPS or something else on the airplane? Looking at those, there's a totally different risk analysis when you're doing it. So the criticality of the system and software is different.
You bring up an interesting point. It goes back to the redundancy question, which is, I mean, redundancy to work has to have the components that are technically redundant to each other, not have a common mode failure.
Correct, absolutely.
And so one question is, do you want a human to still be in a loop? You said you could turn off some part of it and the pilot could still fly it, for example. That idea of should there be a human in the loop or not is a very interesting question. And this week, I don't know whether I believe it or not, but Reuters reported that the NSA has announced they're going to fire 90% of their system administrators on the grounds that that's where their leaks happen, and so they're going to go to all machinery. Now, I think to myself,
They may change their jobs, Dan, but they won't fire them. That would be a real counterintelligence risk.
that was the voice of authority, folks. Okay, fair enough. Fair enough. But the idea of do you turn over the protection entirely to machines, or do you keep a human in the loop is a redundancy-like decision. And I suspect that once you take humans out of the loop, it's irreversible. That whatever you have done to take them out of the loop, you can't put them back in, because now you have a data flow structure and a decision speed and so forth. I mean, as we all know, high-frequency trading on Wall Street, you can't put a person back in anymore. There's a little brokerage that proposed the SEC that when you post a price on the automated exchanges, you had to honor it for 50 milliseconds. And it was shot down by all of the big high-frequency trader folks. You don't have to honor your price for 50 milliseconds. I don't know about you, but I can hardly get my hand off the table until 50 milliseconds. So do I have a role there? And the answer is no. The answer is no. I do not have a role there. This is not investment. This is game theory, if you will. And I don't want us to go in that direction. I'd like to preserve various kinds of fallbacks that do have a human in the loop. And if we have to pay an efficiency price for that, then we have to pay an efficiency price for that. I would like not to say that if the pilot insists on bearing left because the pilot knows something, that he's not going to be overridden by the flight control system. I don't know what I'm talking about, but it feels right to me to say that. I worked for a company called Vertices. We did a data protection product. It was the best data protection, still is, the best data protection product out there. Think of it as the Orange Book reference monitor implemented as a rootkit. If that means nothing, it's cool. Don't worry about it. But that's what it was. And we were installed in a hospital. And in a hospital, we had on the one hand, the chief of medicine said, under no circumstances can this data protection thing prevent getting data. You know, if I have somebody knocked out on the floor, I'm going to look up their medical record, don't get in the way. On the other, or their allergies, just to use your example. On the other hand, you had the chief counsel say, under no circumstances are you going to generate HIPAA violations or anything like it. You know, people who should not see data cannot get it. The solution here was a finesse, which kept, in a sense, a human in the loop. The finesse was, I go to the thing and say, give me David's medical record, and I'm not ordinarily allowed to have it. Little pop-up says, against policy, click here to proceed. The medical director got what the medical director wanted, which is, did not prevent access. The general counsel got what the general counsel wanted, which was, cannot deny that you meant to do it. So you established intent. But that's a finesse. I don't know how many of those there are. But I do think that keeping a human in the loop to make finesse decisions, to make decisions like that and say, no, we really are going to bear support, or we really are going to pull up the medical record of this person who's unconscious in the hall, or whatever it is. I think that's better than turning it entirely over to machines. Anybody who's my age will remember the debate over launch on warning for ICBMs. Do you want that or not? You know, do you want to launch ours when we think we see theirs? The answer is no. The answer is no. But nevertheless, we have this problem because as we speed things up,
Yes.
as we speed things up, keeping a human in the loop becomes harder. I don't know if that was really what you were looking for, but
Yes, I mean, I want to expand this a little bit and really put you on the spot, Dan, and ask you for your opinion where you think the risks are to the transportation sector. It's a critical infrastructure, specifically perhaps
I got asked on a panel a while ago, what malware would I write if I really wanted to write something? So putting aside the question of I don't have the skill to do this, I would write something that changed your Excel formulae by little bitty bits at random forever. And pretty soon you'd have to destroy your data because everybody's copy of the budget would be different. In other words, causing us to do something to ourselves is probably a bigger risk, I think. And no offense to Al-Qaeda, they are modestly good at this, at getting us to do things to ourselves. I mean, I don't think that's really their aim. I think they're much more primitive in their view of what success is. It involves smoke and so forth. But getting us to do things to ourselves is a serious risk. A serious risk in the sense of going away from things that are rare enough. We had terrorists 200 years ago. They just happened to be called anarchists. With the cyber, that does change things because the location independence of attack is a big difference over time. Stephen Jay Gould, who is a paleobiologist from Harvard, who you may have seen a television program he used to have on PBS, early in his career coined a term which entered the lexicon of paleobiologists, and it was punctuated equilibrium, the idea that evolution doesn't occur at some steady slope, but instead it's long periods of nothing followed by rapid change, followed by long periods of nothing, followed by rapid change. In other words, you have an equilibrium and you punctuate it from time to time. And that term of art, I think, applies to our world. All of us who work in cybersecurity owe our jobs to the fact that a TCP/IP stack appeared in Windows 3 for free, and suddenly a machine designed, and I'm not picking on Microsoft for this because it's a good business decision. Suddenly a machine designed for a single owner-operator on at most a private network was connected to the rest of the world where every sociopath is your next-door neighbor. So and you can, by the way, see this. If you look at the rate of report of intrusions to CERT at the time, which got them all.
Yes.
Does not now, but got them all at the
Yeah,
time. There
like
was
this.
a spike in the second derivative, which is a little bit like lighting the solid fuel in the space shuttle. Nothing happens at first. You think, is that all there is? But soon enough, you realize that you can't turn it off,
skyrocket.
and it's whatever it is, 6 Gs, and
Right.
it's impressive. But there was a
And
spike.
they don't keep track of incidents anymore, Dan.
No, they don't. I know. They don't.
Too numerous.
Too numerous. But at the time they did. And so
Yes.
if you go back and calculate the second derivative of the rate of report, there was this impulse function right when, 3 months after the TCP IP stack appeared in Windows. So we all own,
That's
that's a punctuation, equilibrium punctuator that we all owe our jobs to in a sense. Second one, which is maybe 5 years ago, maybe 6 now, something in that scale, where it seemed as if overnight all of our opponents went from being amateurs to being professionals. In a sense, we succeeded in making it too hard to do high-quality exploit development as a hobby. We succeeded. That's a wonderful thing. I'm not making fun of that. But by doing so, now the people who do that can only do it as a job, and they expect to be paid in something other than bragging rights, so they don't share. When it was bragging rights, people would get something and they would announce it to the world and everybody would know, and we would fix it and move on. When it is not bragging rights, but rather money, instead, you don't announce it to the world, so the fraction of all attacks due to, quote, 0 days, unquote, is rising, not because of anything else other than the fact that the people who are finding the attack methods don't share anymore.
Could you explain a 0 day to the audience?
Explain a 0 day. 0 day is a term of art talking about an attack, the mechanism of which you didn't even know was possible until day 0, which is now. You didn't know this was even possible, and here it is. Who is it? Tudor Demetris and Leila Bilga at Symantec published a paper a year ago. It got sort of first runner-up in the NSA's Best Science Paper for 2012 awards that occurred last month, in which they used semantics data to show that when 0 day attacks appear, you don't notice them at first. This is silent failure, again, all over. You don't notice them at first because they're targeted at just Mr. Shaw here or somebody. They're not broadly available. And so when you finally discover that they're there, the question is, how long has this been true? And they were able to show that the average was over 300 days.
The average vulnerability.
The average 0 day vulnerability had been exploited in practice for 300 days prior to discovery in Symantec's database, which is as good as they are. They're not the only one, but they're as good as they are. And by the way, what they do is they're correlating. This is data fusion over disparate databases. But and it was a straight observational thing. It's just like being Darwin in the Galapagos and looking around. It's straight observational. I thought it was terrific science. Nevertheless, the average one is 300 days old by the time we notice it. Well, the question is, what have they been doing in the interval? Now, you don't, strictly speaking, you can't know that. But I go back to the point that when vulnerabilities are discovered by people who are working at it as a job and they're being paid to turn them in to whoever their paymaster is, the fraction of all attacks that are due to 0 days, it should not be surprising that it has risen, and it has. It's risen. So if you read the press and you say, where are all these 0 days coming from? Why is everybody relaxing? That's not the case. It's not because we're relaxing, it's because the dynamic of the game has changed. If there is a third punctuation, we are in it now, and I'm not certain about this, but it is the demise of the general purpose computer as a consumer durable. As you probably know, it's been since October of 11 where the majority of memory chips shipped were going into computers and now going into communication devices. I don't know if that changes everything. It certainly is the driving factor for the bring your own device to work thing. But we may be in the middle of a third punctuation. You can't tell these until after the fact. I mean, you can't tell that this has happened until you can look backward a little bit. But we've had at least those two.
And we certainly are seeing an expansion of attack surfaces as a result of what you're describing.
Term of art. Attack surface is how many ways can you do something to something, well, just think of it as drawing a circle around your hand, what is the length of that? And if I put 2 fingers together, it got shorter. And if I put 3 fingers together, it got shorter. And if I grew 10 more fingers, it would get longer. You get the idea? The attack surface of our systems goes up probably by the square of the number of interconnected parts. There's Metcalfe's law, which everybody's heard of, I suspect, and that is that the value of a network is proportional to the square of the number of communicating parties, because that's the number of potential conversations that might take place. I think these days Reed's law, which is, by the way, that was preceded by Sarnoff, which was for radio. The value of a network is proportional to the number of listeners. Metcalfe is proportional to the square of the number of communicating parties. Reed's law, as in Bob Reed, back to Reed, Clark, and Salser. Bob Reed's it's not n to the 2, it's 2 to the n, because if you talk about forming groups, like social networks or mailing lists or what have you, that the number of potential parties goes up as 2 to the n, not n to the 2. I think our structure for certainly a lot of merchant systems on the internet, electronic commerce, you go to a travel site, you have no idea how many you're attached to there. Buy a little product called, I don't know what platforms it's available for, Little Snitch. It records all the outbound networks that you've gone to. It's fascinating. The average travel site is touching nearly 100 different domain addresses in the process of coming up. Now, you might say, so what? It works. I agree with you, but if I'm an opponent, all I want to do is go after one of them, because all I need is one of them. And for what it is worth, Kaspersky Labs announced yesterday that you should not visit the Chinese language website of the Dalai Lama because it's heavily infected. So you visit the Chinese website of the Dalai Lama and you get malware that in turn brings in other malware and so forth. Melissa Hathaway, when she did the 60-day review of cyber policy for the U.S. at the outset of Obama's administration, one of the things that I thought was a memorable term of phrase, and this is close to a quote but not quite, which is that the primary targets are the defense industrial base and other firms whose intellectual property is of a considerable fraction of the U.S. total output. Secondary targets are the counterparties of those. Tertiary targets of those can be used to mount attacks against the first two. The secondary ones, the counterparties are ones which are ones that I do think matter to you in aviation. Because if I don't have to go after you, but I have to go after one of your suppliers, it's probably easier to go after your suppliers. In fact, I think mid-tier firms are the ones that are great at risk, because the big ones can afford a legitimate, full-strength, state-of-the-art cybersecurity program. The little guys don't have enough to steal. It's the ones in the middle that are both have something worth stealing and are not in a position to buy world class. They are the counterparties. They are the counterparties. That's where you would go after. And I don't know how they got the Dalai Lama's website, but I'm sure it was that kind of thing. I'm sure there was a link of some sort that led to going elsewhere. I mean, that idea that someone may attack you through a counterparty. What is it? eBay. eBay takes down 1,000 fake eBay sites a day. Why would there be fake eBay sites? The answer is they're not selling something. They're looking for you, and that's all that's required. Or to continue, because eBay lets you upload your own. I'm not making fun of them either, by the way. They let you upload your own HTML and JavaScript. That means that eBay can be itself immune to attack, and yet I can attack you by way of them.
Can you explain, I think, do people understand drive-by downloads? You open your browser and get infected, everybody's up to date?
And most of those are very mild. They then decide what else to do. And some of the better malware, the first thing it does is look around and say, are you running Little Snitch, or are you running Symantec, or are you running McAfee? And if so, just erase myself and go away because you're not a plausible target. Cormac Hurley and, what is that other person's name? I'm sorry, I'm slighting someone because I'm enough of an academic. I like to give credit where credit is due. Cormac Hurley is at Microsoft Research. I'm forgetting who the other writer on this paper was. But they showed, how should I put this? The title of their paper was, "Why Do Nigerian Scammers Say They're from Nigeria?" And the answer is, if you're looking for people who are stupid enough that you can separate them from their money by saying that you're a scammer and you're from Nigeria, anybody who answers you has self-identified as being stupid enough to separate from the money.
Oh, that's really good.
And it's a behavioral economics paper.
That is excellent.
It's wonderful. That's the title. Why do Nigerian cameras say they're from Nigeria? Cormac Hurley. On the other hand, we are frequently guilty of overhyping the risk as well. Frequently guilty of that.
Can you put that in context for us, Dan? Dan, how do you see?
Well, the bit
risks?
about we lose $1 trillion a year. I don't think.
Where's that number coming from?
Yeah, where's that number coming from? And the answer, I think, is the number is coming from one-upsmanship in the marketing departments. The most recent work on that is Stuart Baker and James Lewis. James Lewis at CSIS. Stuart Baker is former general counsel of the NSA, who I suspect he's still...
He's practicing law at Steptoe Johnson.
He's still at Steptoe. Yeah. They just did a paper on what the size of the threat really is. And of course, it's 3 orders of magnitude smaller than anybody else says. But it's still real money. Don't get me wrong.
Pretty big, too.
Huh?
It's still pretty big.
Oh, it's still big. It's still big, but it's not $1 trillion big. It's big, but it's not $1 trillion big. Of course, all of those beg the question of, we have a false negative and a false positive problem. And we have a problem where if you don't know that an attack has taken place, back to the 80% data loss, how do you know what the long-term effect of that is? They all come back to that. As a public health guy, as a former epidemiologist type guy, the way you rank suppose you're screening for something. You want to know how many people have latent disease of some sort in the population. What you do is you first administer a test that has a very low false negative rate, has a high false positive rate, and is probably cheap. Then you take a second test, and the people who came through the first one, you apply the second one that has the opposite. So the idea is you apply a cheap test at the tolerance of false positives, but no false negatives. So everybody who's ruled out is clean. And then you apply a second test, which says that it's expensive, but now the people who come through actually have the disease. We do that a little bit with some kinds of behavioral intrusion prevention, but I think we'd have to do more things like that. And in turn, you rank such a test program as what is the predictive value of a positive? And the predictive value of a positive is an idea that information retrieval people have that. Library science people have that. And, that idea comes up a lot. I don't know quite how to do that. Anybody who says they've been in security for 20 years, which I say, or 30 or whatever, the next question you should ask them is, and why haven't you fixed it? Which it's a question you should ask. It's a question everybody claims, I've been there so long, I know everything. Say, well, why haven't you fixed it? It's the right question to ask. I just think we are not going to get anywhere unless we have better measurement tools and the discipline to use them. The discipline to use them. And I don't know what to call it except discipline. What's an example? I mean, you try to train people to not do stupid things. Do you have a way of measuring whether they did fewer stupid things after you trained them, and do they revert to their prior state in a while? In medicine, you do this with placebos. You give people, you do clinical trials where the person administering the trial doesn't know what they're giving the patient, and the patient doesn't know where they're getting the real pill or the not. And you do it that way. Do we have an analog to clinical trials here? There's not just safety, there's also efficacy.
You're really talking about turning this into more of a science than an art?
Well, I'd love to. I wish I knew how.
That conversation is bubbling, but you're right, it's challenging.
I don't know.
The boundary keeps growing. I'm using some licensed folks because this conversation has been really engaging, so I'm stretching this interview a little bit longer if you'll indulge me. The panel consists of myself and Dan and a few others, but I'd like to keep going with this, and I also want to give the audience some opportunity to question you, Dan. It's a privilege to have you here. So, you were starting...
A, it's not your last chance, and B, I have an email address that I read, so, just...
Okay. Well, if you could just sum up the the threat vulnerability landscape as you see it today, the progress we've made, how aviation might fit into that picture? How would you characterize things? The state of the field?
I think it varies by field, and so if you want it just by aviation, I wish I knew more, but I would guess that.
How about in general then first, and then?
Well, the fact we're embarking on the smart grid and embarking on electronic health records are, by policy, vastly expanding the attack surface, and I worry about that.
Yeah.
Okay. With respect to the ordinary person and their ordinary use of the internet, I suspect that the drive toward auto update, putting aside that it screws people who need certification, putting that aside, I think the drive toward auto update is necessary.
People aren't going to take the time to patch their own
And certainly
system.
those who are on private networks, which I will call Verizon cell network a private network, I'll call AT&T's network a private network, and so forth. Those where the operator has control over the endpoint device, those are likely to be better managed by a lot than the general purpose computer. And so I went back to, are we in a punctuated equilibrium situation where the general purpose computer, which by the way I want, and I suspect some of you want, I want a machine that I can tinker with, that's what I do for a living, but not everybody does. Not everybody does. The appliance aspect
Yes.
is strong. It's strong. There used to be a joke of how many CEOs ever learned to type, and now it would be how many CEOs have ever typed with anything but their thumbs. It's, but I do worry about that. I worry about the merging of biology and cyber, not just electronic health records, but in general.
Right. You're talking about implantable devices and things
Right,
like
implantable
that.
devices. If you want to look up somebody's papers, Kevin Fu, who is now at University of, that's last name is FU, now at University of Michigan, I'd certainly start with that. Understanding the economics of all this is something that we have to do because we can't just keep demanding perfection, because perfection always involves, on the cost side of the ledger, dividing by zero. But the workshop on the economics of information security is worth looking at. This week in Washington, not here, the Usenix security meetings have good stuff, and the question is, if what you might want to do yourself, and you said you just went to Black Hat, what you might want to do is skim the titles of the papers of these things as your best measure of where is the leading edge.
I agree with you because it
Even if
tells
you don't want to
where-
read them.
Correct.
Even if you don't want to read them.
Right.
I would suggest the discipline of, for the top 5 conferences,
Black Hat, what?
Black Hat, Usenix, the DEF CON, if you care about network security, NetSec, I'm just saying there's a small number. Professor Gu at Texas A&M keeps a general calendar of all of them. But just scanning the topics to see what's interesting. I will say that what happens at RSA every year, partly I think sometimes it is just showmanship, and it also happens at Black Hat. Every year there's a paper or two that get pulled at the last minute.
We had Barnaby.
Sure. Well, not just because the presenter dies, but because somebody, sues. But what papers get pulled at the last second. Here's a question for us all. I know this is not answering what you asked,
No,
but
it's okay.
a question for us all is, should vulnerability information be public or not? This is one where one is reminded of Churchill's remark that democracy is the worst system except for all the others. I think that vulnerability information probably ought to be public. Here's a proposal. Again, I'm not answering your question, I'm sorry.
That's okay.
But here's a proposal, which is the U.S. government has enough money. We spent the Soviet Union out of existence. We really did. That's how we did it. We have enough money that we can corner the world market in vulnerabilities. We should do it. If you show us a competing offer from the Ukrainian mob or whatever it is, we'll give you 10x. We should just corner the market and collapse it. And even if there are people who will not sell to us, they will only sell to the Ukrainian mob, they know that as discovery of vulnerabilities is increasingly automated, that someone else will find that and they will sell to the Americans. So the value of the stockpile of unannounced vulnerabilities can be zeroed, no matter where you are, if we are willing to simply corner the market. Use our remaining great weapon, which is the Treasury, to corner the market. At the same time, I'll agree with General Hayden on this, or at least I think I'm agreeing with him. It's not like he answers the phone for me. And that is, we should make them public, because if we don't make them public, the suspicion of everybody will be that we are stockpiling them, and that will not help. That by making them public, and maybe not the first day, because some things are hard to fix. I don't mean you flood the world with, here's 500 new ways to take over GE Healthcare or something. But I mean, we make them public, because only then do you ensure that there is a fix in the long run. A date certain that we will announce this by such and such, or something like that. But I do think that simply cornering the market, I know that this, what was it H.L. Mencken said about, for every problem there is a simple solution that is dead wrong. It's possible I just proposed that. But I would like to perform this experiment and say, if we bought them all, what would it cost, and how could we use that of value? Maybe we have a new treaty organization like NATO, that we share it with those who are inside the loop. There are obviously countries we would never share it with. The Syrian Electronic Army does not get any, and so forth. But trying that and straight out buying it, because the vulnerability traffic is now real. You can make real money selling vulnerabilities.
And we have the Microsofts of malware out there now, right?
Oh yes, absolutely. And so the question is, how do you fight that? And I think the answer is, you fight it with what they have already, in jiu-jitsu terms, said, this is what motivates us.
Money.
Money. What have we got that nobody else has got? Well, the borrowing power of the U.S. Treasury. I know it's a bad time to suggest this, but
I was going to say something.
But what else are you going to do, in so many words? There's a different question. What do you do with abandoned software? Back to XP and OS X 10.5 and below. What do you do with that? It is possible that the right answer is that you open source it. It is possible that that's the right answer.
Yeah,
because there are people who would fix things, and there are also people who would say, we've analyzed this. It's a good 10 years ago, Microsoft lost, at the time when their entire source code was 7 CDs worth, they lost 1 CD's worth. Someone posted it on the web somewhere. 3 weeks later, attacks against that began to appear. So it's a partial source code pool, and it was done by source code analysis. Now, mind you, all the operating system vendors have already shared their source code with all the governments, some of which don't like us. So that's not the issue. The issue is what do we share when we abandon a source pool that other people depend upon? I can tell you of a bank in New York, which I am absolutely certain is still using NT4 for their foreign exchange desk because of the rule, never touch a running system. Never break something that works. It ain't broke, don't fix it. I'm sure they'll have to fix it one of these days, I'm sure of that. But we are accumulating a legacy in our critical infrastructure.
Yes.
That we don't have an estimate on.
Correct.
I don't think we can continue to do the same things we've been doing and expect a different outcome.
And you're bringing up something interesting that you alluded to before about looking at this as systems, and not systems the way we typically think of a computer system, a network system. The systems are, the scope or the boundary of those systems is immense.
Correct me if I'm wrong, there's no academic result yet that answers the question of, is security composable? Can you take two secure components and hook them together and expect the result to be secure by definition because these were secure components? Is there a proof either way? I don't know of one. I'm not aware of one. So
and not only that, when you hook these systems together, pieces of that system are constantly being swapped out.
Let's assume that there's a proof somewhere that security is not composable. Now the rise in the number of components is the thing that you were after earlier, which is, are we getting better or worse? And the answer is, we're deploying a lot of components. The rate, if you look at Apple plus Android, the comment earlier about that, the rate of appearance of new apps is a little over 1,000 a day. That's a lot of attack surface.
Exactly.
That's
And
a lot
made
of-
by multiple
Even if
sources?
Even if 999 of the 1,000 die a silent death and soon. Even if. But that's a lot of attack surface. There's a company called Veracode that, again, I work for In-Q-Tel, and this is not an advertisement, but we've invested in them. What they do is they analyze source code pools or binaries. They can reverse engineer them, looking for flaws in the data handling or the control structure. And we paid them to run all of the open source software in common use in government through their apparatus. They publish an interesting little report about the flaw density that they find in people submit their work products to them to be analyzed. It's like getting, it's like sending, tires to a test facility, which I'm sure aviation people do. You send your software to these guys, and they look for it, and they score it. What's fascinating about that is scores have been constant now for a while. So even people who are trying harder, the attack surface issue and the trying harder issue are currently amongst their clientele, mind you, who are particularly motivated people willing to spend real money on doing this. What they're finding is it's largely flat.
Because the increasing number of...
If for people who are trying really hard, it's largely flat, what about people who are not trying really hard? And the answer is probably rising.
Mm-hmm.
We're back to the Red Queen. You've got to run faster and faster to stay in the same place. There's a measure. It's an indirect measure. But I don't think we have direct measures. We have to sort of, in some sense, grab all the indirect measures we possibly can. And theirs is a real one. Verizon, Symantec, McAfee, Mandiant, a lot of these folks put out reports like this.
Yeah.
If you're a part of a large team, I would suggest what in academia would be called a journal club, which is where you divide up all the journals in your field, and I'll read these 3 and tell you if there's anything interesting to my colleagues' work, and you read 2 others, and this gentleman here reads the other 4, and we sort of share the task of reading. You might want to take all these reports and just parcel them out and say, I'll read the semantic one. If there's anything that applies to making, if any of you are, let's say, engine makers, anything applies to making engines, I'll let you know, or embedded systems or whatever it is. Myself and another guy, we did a not quite an attack, but an experiment with smart cards. Smart cards, you know what I'm talking about, right? And does the word fuzzing mean anything to you? Fuzzing is the idea is that you send bizarre inputs to a system to see what happens. If I discover that I can send 50,000 lowercase a's to a database system, I then gain super user privilege. That's useful, right? So you send bizarre inputs to systems to see what happens. And by and large, if you crash them, you're probably near where a security fault is, because if you can cause it to crash, odds are you can cause it to almost crash and give you something that it wasn't supposed to give you. That's the idea of fuzzing. And we fuzzed smart cards. We fuzzed smart cards for what it is worth that had been in use. We were fuzzing cat cards, if that means anything. We were fuzzing cards that were right out of the box, ones that had been initialized, and ones that had been in use in top secret environments. And what we found was that we could get failures almost assuredly in a matter of hours with all of them, and that they were all different. And there's no explaining that, except that quality control on the other end, quality control. Maybe that doesn't matter, but the thing about that illustrates is that the difference between who was it? Hugh Thompson. A while ago drew a lovely diagram, Venn diagram. I'm going to draw it in the air for you. Circle overlapping with circle. This one was design, and this one was implementation. And the argument was the things that are in the design, and they overlap almost entirely, but the things that are in the design but not in the implementation are quality faults. The things that are in the implementation but not in the design are security faults. And your testing almost always says it's supposed to do this and this and this and this and this does it. So you're testing for quality faults. How do you test for it does things that we didn't know that it could do and we didn't tell it to do and we don't even know that that's in there? That's the problem. Yes, sir.
Well, the answer to that is in aviation, there's a DO-178B certification or process that's for design assurance. And two-way traceability is the solution to that. One is you make sure if your requirement is a hammer with a hickory handle, it has the hickory handle, and it doesn't have a claw that you didn't want. So if you are using the DO-178B, it requires that you look for things that are there that are not supposed to be.
I think that probably gets harder when you're talking about complex cyber systems. And I'm not making fun of your remark at all. I wonder if there is a level of complexity at which that's no longer possible.
It probably doesn't take long to reach that threshold.
Mm-hmm. Which is, I suspect, why, back to earlier comments, that the failures we now see are ones that are interactive. You know, this component and in its failure mode and that component in their failure mode contribute to each other in ways that were not even analyzable on a component basis. And I don't know how to. I don't have a magic bullet. There are no magic bullets, but I certainly don't have one for that.
I think I'm going to ask Dan if he'd like to say any parting comments to the community here, and then I see a pent-up desire to ask him questions, which I want to tap into. So, Dan, do you have any summary remarks or thoughts or comments?
Two rules of engineering that I learned a long time ago that are sort of jokish, but those of you who are engineers, which if I remember correctly, were an awful lot of hands.
There's a lot of people here. Yes.
One was never test for an air condition you can't handle, which is an interesting idea. And the other was Fred Brooks' comment in Mythical Man Month, which is that there comes a point in the lifetime of any system at which further repairs to it are a mistake because they're likely to introduce flaws with the same probability that they would remove them. Mm-hmm. I don't know quite how to apply that to cyber because we're piling on at such a rate.
Yes.
Maybe, I don't ordinarily suggest this, but maybe slowing down progress a little bit, at least on things that we consider to be critical. I mean, what is the nature of critical infrastructure? PDD 63 defined it as those facilities or something or other. I'm just quoting this from memory. Those facilities which are essential to the minimum operation of the economy or government. What are those? And those might well want to run slower. Those might well want to run slower. I think that aviation probably falls in that category because it is essential to the running of our economy at this point. I cannot imagine doing without it at any scale. I don't know about where you were on 9/11. I was in a roadside motel in Alamogordo, and I didn't get home exactly quickly. It's essential. It's absolutely essential. So maybe the hysteresis, the hardness of getting recertified is your greatest protection. Not the engineering that you're getting recertified, but the slowness of the recertification might be that. On the other hand, I fully realize you're competing with the rest of the world that doesn't have the same rules. And I don't have a magic bullet for that. The other thought I might give, this is an engineering rule too. I'm sure you've heard this fast, cheap, reliable, choose to. It may well be that in the broader society level, it's freedom, security, comfort, choose to. But there is a kind of mutual trade-off here where we can't optimize everything at once. What is it called? There was a theorem. Sorry, I'm losing the name. There was a theorem in database research that said Broom's theorem, which said that resistance to network partition, consistency, and availability fall in that category. You can't get all three at the same time. You can't get resistance to network partition, which means that if the network fails, the various instances don't drift apart. Consistency and availability, that you can't get all three. You know, we may well find that there are other such, maybe there's a fact of nature that we come across these kind of three-way mutual balance phenomena. Maybe it's out there, but the critical infrastructure, I think, has got to say, suppose that there are three for us, and it may well be that it's fast, cheap, and reliable. Suppose we have to give one up. Which one are we going to give up? And I don't think it's reliable. Whether it's fast or cheap, I don't know. But we have to choose, and we are not served well by either political or marketing talk that says you can have it all. And we get that all the time.
Yeah.
We get that all the time. I see it all the time. I work for a company that looks at investments. I see it all the time. If you just install this, you're happily ever after. You know, happily ever after until somebody figures out that you should have done the following kind of engineering, but that you didn't do.
Mm-hmm.
I mean, we were talking about a mutual friend earlier, Becky Bass. I mean, is intrusion detection still relevant? Or is intrusion tolerance the way you have to go, as an example? Is that, you know, do we say that we're going to detect intrusions? Maybe that's not important. Maybe tolerating them is more important. I'm just making this up, but you get,
No,
you get what
I
I'm...
think this is an interesting subject area, because the CISO at UW has long said that he manages our network based on assuming breach and tolerating people on the inside and diverting attention away from the important assets. We're very underfunded, but then I guess most organizations consider they're underfunded for security support. He doesn't.
Well, part of that's the asymptote. That was Shamir again. To have your risk, you have to double your expenditure.
Yes.
He also said that in his Turing lecture. So.
Right. Well, it's been a real privilege to have Dan here commenting. This is, as I said before, for those of us in the cybersecurity field, he's iconic, and he's been part of leading thinking about cybersecurity for as long as I can remember, an inspiration to all of us. And so I'm not sure, Dan, if we have all the questions answered. Again, you said you were at this for 30 years or 20 years.
Yeah, and
what have
you haven't
done
asked
for
me
us?
yet, why haven't you fixed it?
Yeah, why
Yes.
haven't you fixed it? But I think that this gives you a pretty, although it's not comforting perhaps because there's no black and white to this, but it gives you a sense of the state of the field. And so I'd like to thank you. And what I'd like to do,
Let me be clear, thank you for your time as well.
well, I'd like to open this up. I think, Wayne, you were going to help moderate a little bit. We've brought some of the people up front. Emilio, do you want to come on up? And
Yeah, but what I'd like to do is invite one of the gentlemen up front here, Paul Kurtz, who come up and join us, and also acknowledge Joel Brenner's in the
come on,
audience too.
Emilio.
Joel is
Please
a former prosecutor,
Yeah.
federal prosecutor, also been in Intel business for a long time.
I'm pulling
And,
up.
So in essence, he may be able to, from the audience side, answer some questions. Paul's tenure here is because he's going to be leading the Cyber One panel later on, so I'd like him to join us. Go ahead. And we're all friends up here, so we can answer questions
Come
and
on,
go,
Emilio.
and go from there. Run up. So we'll just kind
Just
of grab
gather
some chairs
around,
here.
you
Go.
wanna-
Maybe
Yeah,
we'll
yeah.
grab some chairs, Barbara. If you want to just stay there. Here.
Oh, I thought we were all... All right,
Go ahead.
Here, Dan, I'll give you your, everybody knows who you are, but.
What we want to do is basically answer some questions. I mean, you have a rare moment here. You really have a very rare moment here to answer some questions, to ask questions to some of the key folks within this industry. And I'm going to let Wayne get a kind of monitor that. Just Wayne, if you want to just kind of give a quick intro as to who's who.
I got it.
Okay. This is an unusual thing. We were going to just have a four panel, but I wanted to go ahead advance it on out, because.
Okay, we've got a lot more people up here now, and so Paul, like what Dave was saying, he's going ahead and he's going to be running the next panel this afternoon, which Dan is going to be at as well. Paul, you want to just hit real quick as far as, you know, your credentials and so forth, just to let everybody know who you are?
Sure. I've been, my career has taken me in a strange path. I've worked on weapons non-proliferation, Iraq, North Korea, places like that. I worked on counterterrorism for a while. And then I got involved in cybersecurity in 1999 at the behest of Richard Clark, who will be speaking to folks later. And spent some time at the White House working on and ran a trade association focused on cybersecurity. Now I'm with a firm called CyberPoint, and we're based in Baltimore. And we like to solve hard problems. We do that for the U.S. government, we do it for governments abroad and for the commercial sector. And I'll stop there.
Remy is, he's kind of a white hacker, but he's also very much an engineer from the standpoint of a security developer. He works both with the government and also in private industry. He's working right now for ANRC, and he was in our panel yesterday. Anything more you want to say, Remy?
Just mainly my focus is reverse engineering malware, exploit development, and tool making. So a lot of the technical stuff.
And Emilio is right next to him, and Emilio Iacello, he actually now works for eyesight, and before that he's worked in the government, both for the State Department and DIS, and so Emilio, anything that you want to share more?
I think that pretty much did a great job on that, but yeah, we just support government and corporate clients in this threat space.
Joel?
Yeah, I was the Inspector General of NSA for 4.5 years and then later as senior counsel there, and in between I ran counterintelligence and policy and strategy for the Director of National Intelligence. I'm the author of America the Vulnerable Inside the New Threat Matrix of Digital Espionage, Crime, and Warfare, which is coming out later this month in paperback under the title Glass Houses. And I have a consulting and law practice in Washington.
Dave Shaw, he already told you he's a former fighter pilot. I'm not going to hold that against him. And the reason I say that is because I was a special ops pilot. And but Dave also used to be a partner for Arthur Anderson. He's done a lot of consulting, and he's the CEO of GVA. Barbara, you've already met. I'm Wayne Washer, and I'm the COO for Global Business Analysis, GVA. After I was done flying, I was also a program manager and a program director at a SPO, the program office back at Wright-Patterson Air Force Base. And then I've also been an account manager for Russell Investments, and so I work now with Dave. So as far as some of the questions, does anybody have questions right off the bat that you would like to throw up here? I've got a few that I can go ahead and solve if you'd like. Go ahead.
Dan, I wanted to ask you a question. You mentioned about ISACA, the CISA CISA organization. Is there any work going on in ISACA on extending the COVID framework for aviation?
I'm sure someone else can answer that. I don't actually know the answer to that. Anyone?
Yeah, I saw that.
This is the COVID?
Yes.
Yeah, COVID, extending it, yes.
Frankly, I don't know. I should know. But
Extending it for aviation?
Yes.
I'm not aware. If you give me your card, I can.
If it isn't, this would be a good time to start.
yeah.
Correct.
I think you're elected.
Go ahead, Mike.
This could be for Dan or anybody else who wants to comment on it. If we take lessons learned from nature and the autoimmune system and bodies and the ability to attack different diseases, has anything been done on that analogy relative to looking at adaptive software and things where it senses the traffic flow and then says something is anonymous and either shuts it down or redirects it to a path of least resistance so that it compartmentalizes the attack or makes changes within the software that addresses that?
Well, I mean, the closest thing you're going to see to that right now that I've seen is just heuristic-based analysis. And you see that a lot in the more advanced AV systems, and IDS systems. So just behavioral type analysis. And then a little bit just to learn from those behaviors in order to categorize them. You see a lot of different honeypot technologies that are growing up. I know Barbara works a lot with honeypot technologies and research in that area, as well as do I. Yeah, the behavioral type is basically.
I'd be interested more in an industrial control system type environment.
There is a honeypot out now with industrial control.
A SCADA type honeypot is out there right now.
Yeah, if you go to honeynet.org, you can get quite a bit of information. There's great papers there, and it'll describe it too.
The head of the CS department at U of New Mexico, Stephanie Forrest, spent a lot of time on this with her students. The bibliography from that group, again, Stephanie Forrest with 2 R's, would be a good place to start. There's a guy named Larimore who was at University, forgetting his last name, which is embarrassing, who was at University of Colorado Boulder till last year, and has now gone to the School of Public Health at Harvard, where they're looking at, they're applying infectious disease models to network threat models to diseases. It's pollinating in the other direction. And there are several others. There have been a lot of people who want to look at that.
Mike, one of the things that I've heard recently from engineers at a really large aviation company is that the really sophisticated intruders know when they're in a honeypot. And what I think he means by that is that honeypots is a species of strategic counterintelligence. It's an attempt to mislead. Strategic counterintelligence is hard to pull off because in order to make the ploy, in this case the honeypot, credible, you've got to build out a whole environment around it. That's very complicated and difficult. If you want to, for example, put 3 forms or 10 forms of your critical, some critical engineering design or secret available to be stolen so nobody knows which is the right one, you've got to also build out the behaviors around that don't let somebody pick out the one out of the 10 that matters. This is tough.
Yeah, I was going to say that the malware has the ability to probe. I think Dan mentioned this earlier. Probe and tell where it is, and it's getting much more sophisticated. Pacific Northwest National Laboratory did a lot of work about adaptive systems. I'm not sure how much of it's public. They were looking at deception models, and some of the folks that I know of that are working in this space are exploring what you're talking about. If you assume breach, that they're already here inside our networks, then you've got to be thinking of different ways to confuse the enemy and get them all occupied with things that don't matter, so you protect what's really important. I've seen some real interesting models for designing networks, sending out chaff that confuses folks, number of techniques.
Dave Dietrich works on that.
Yes, he does.
Dave Dietrich from Washington is certainly someone to look at their work, or Vern Paxson at Lawrence Livermore.
Other questions?
I wonder if the panel might talk a little bit about the general aviation ecosystem in which we're looking at in its entirety, where possible nodes of vulnerability may exist, and this sort of leads into the panel that's coming up in this afternoon. But if they could just at least touch on the basics of that, I think it might give everyone a perspective of the complexity of the landscape.
Paul, why don't you start?
Yeah, let me try. It's almost a lead into why people should attend the panel this afternoon. The aviation community is come together, and it's largely the private sector that's come together to look at how they might impact or affect the security of commercial aviation. In other words, government hasn't necessarily been at the table. Government's been informed, but it's not really a discussion about next gen. It's about what Boeing, Airbus, the carriers, the airport operators, what's within their realm of control. How can they improve their security? It's also, when we think of the ecosystem here, certainly it's a problem, and that's the loss of intellectual property. But it's not necessarily the focus in this particular exercise. It's been more of a focus on how do we maintain surety of the commercial aviation system. So it does what it's supposed to be doing, so it continues operations, so we don't have disruption in that. So there is, this afternoon we'll be talking about a framework that has been put together that I think is, I'm not getting too far ahead.
No, you're fine.
Inviting comments from everybody, inviting participation from people to make it a stronger, better framework so we can actually develop a prioritized roadmap for action. So it's a promising exercise. A good deal of work has been done already, but frankly, the really hard work is ahead of us, as Dan has so eloquently talked about this morning.
I think some of the other comments here too, that the aviation system, the aviation ecosystem has been described here, is largely siloed in many cases. And as such, that produces a degree of vulnerability, and it's siloed simply because of the various technologies that are invoked within that system itself. And so what Paul is saying is the information sharing, and I know that Boeing is moving forward with that, the ISAC and several other things, that the information sharing is absolutely critical at this point in time, so we understand how that ecosystem blends together as new technologies are introduced, how those new technologies, as Dan puts it, create more vulnerabilities. If they do, if they don't, but how are we going to go and protect that? Barbara pointed out too that we need to begin to enter in, the cybersecurity into engineering right at the very, very beginning. Otherwise, at the onset, it becomes almost an integral part of that process. I was talking to a senior product engineer that produces, on the flight down here, that produces parts, process control parts, that are in airplanes, that are in trains, planes, and so on like this, in various transportation systems and in manufacturing. And I asked him the question about where do you introduce cybersecurity, and his comment was, we leave that to to my CTO. And I said, no, that's not what I was asking about. I was asking more about your product security itself. How, in fact, do you invoke cybersecurity, because you're E-enabled in many of the parts that you have. And he said, he was totally confused. He said, well, I'm not sure that we do that. And I said, okay, do your product engineers, do your engineers even consider cybersecurity up front? And he said, I guess we don't. And that terminated the conversation right there at that point, because we couldn't go any further. But I think, though, at this point in time, that ecosystem, as we say, is very complex in its own nature. But in itself, it's very highly integrated. And so the thing is, we need to integrate our information sharing, we need to integrate all that we do and understand what that ecosystem really means. And as I mentioned before, as we enter in new technologies, we need to make sure that those new technologies fit into, and we begin to grow into cybersecurity all the way from the very entrance.
Can I add something there to a historical point of view? The financial industry was heavily troubled, is less troubled now by so-called stock pump and dump schemes. You try to get people to buy a stock because you tout it on the internet or what have you, and then people buy in, and the person who actually is running the scam has already bought in, and when it sees the price tick up a little bit, they sell. And the financial community has a very effective way to share suspicion of this particular ticker, this particular symbol, is being part of such a pump and dump scheme at this time, turn off trading in it or what have you. These are, in a sense, ankle biting problems from the point of view if you're a Morgan or a Goldman or what have you. But the fact is, it's automated, and every morning they do this, and it has largely caused that particular kind of financial problem to go away. Maybe there's a model there. Maybe talking to the FSISAC about that would be worth doing.
And I'd like to pick up on what both these gentlemen have said. You're talking about engineering security into products. I think that what Microsoft was able to do to turn around their development process is an interesting model. They certainly have developed secure products that are recognized by Gartner as far more secure than the blue screens of death that we may remember from the beginning of the last decade. And they turned the ship around by developing processes and procedures that they've made public, and they really worked at it. And so I've been involved with implementing some of these processes in how we teach computer science to students. We're still teaching computer science the way we always did, but the ACM is now leveling a requirement that they incorporate some of these techniques. So what I'm saying is you've seen an industry make changes that have begun to influence academics, and it's slow, but it's happening. The other thing I was going to mention, when we think about the aviation industry, we have to look at where we bound it. We need to use systems thinking, and so where we bound the industry is important. I have a colleague in England who is working on protecting SCADA systems that govern parking at airports. And his point is you could really sow a lot of confusion into the flying community and the aviation industry in general by messing with the parking controls at an airport. You would know better than I. But the important point is there are nodes in this system that we have to be sure we include because they may have an impact on the entire industry. But I was going to ask Remy if he might talk about some of the things he's been playing with, because you've been looking at some of this.
Yeah, is that so I guess there's a few different technologies that I've been researching. So the aviation area is completely new to me. Barbara asked me to speak to this panel. I haven't had any exposure to a lot of the systems since a lot of them are closed to begin with. But as I've been doing a little research, I've been looking at a lot of the hobbyist aircraft software that a lot of the hobbyist pilots are using. And yesterday I found something that was pretty interesting that I'm going to take a look at more. One of them was an RF collision detection system that's open source that a lot of these guys are using. And I guess from what I've read is that this detection system, if you get close enough or if it detects a collision, it will automatically take control of the aircraft for you. So there's a point of vulnerability there. There's also ADS-B, which is another protocol that's being, I think by 2020 is it? That it has to be in all aircraft by 2020. I believe most of Australia is already over using ADS-B, but essentially what that is it's a protocol that allows, if you guys, I'm pretty sure if you guys aren't pilots, I don't know. But essentially what it does is the air traffic control is allowed to see where all the aircraft are in the air, but with a $15 dongle you can buy on Amazon, anybody's able to pull that information in. And then even going further than that, instead of just having a receiver, there's also another attack vector that could be mentioned that you could transmit certain things. So there is attack services out there, just from a few days of research that I've looked at. So it's an interesting area, and I like to take a look further at it if I have that ability or doors open to that. So.
Well, may I? The most troublesome thing I've heard this morning, not at all for the first time, is that in the power grid, for example, engineers are terribly resistant to the notion that they're vulnerable. There are big cultural aspects to this ecosystem that we're in, and that they get lost easily in the technological conversation. Dave, you were giving an example of a cultural issue. And a failure of imagination is one of them. Why would anybody want to muck up the system? Well, there's a huge amount of unattached malice in the world right now. There's a tremendous amount of it. And if we get our hands on Edward Snowden and bring him back, for example, that's going to spike. People are going to look for things to disrupt. They're going to want to disrupt the power grid. They're going to want to disrupt the airline system. They're going to want to cause the most trouble because they're angry. And, we didn't think anybody wanted to fly airplanes into buildings either. Engineers need to begin to think about how their discipline can expand its understanding of the world to address problems that haven't happened yet. There's an enormous resistance in the engineering community to coming to grips with security problems that haven't yet occurred. We're now talking about problems that haven't happened yet and that are likely to happen.
We just don't know when.
I'll just say there's a balance there, and I totally agree with you on that point. The problem we have is the engineers hear about things that are happening, and from people who don't understand how airplanes and the aviation system works, and such as TCAS, Threat Collision Avoidance System, which is the system for TCAS on airplanes, does not take over control of the airplane. It just gives guidance to the pilot as to what he should do. He has to make the final decision. ACARS and what ACARS does and does not do, and a lot of it is trying to say, yes, there are credible things, but there's a lot of what I'll call fuzz out there around, no, that's not possible, and not being accused of being a naysayer because we say it's not possible, but also saying, yeah, there are some nuggets of things that are in there we're not going to talk publicly about.
Right.
But there are some exposures in there where engineers in their safety conscious say, in their safety mind say, well, why would anybody do that? And we have to remind them, well, because somebody could be trying to do bad things to the airplanes. Where are all those things we designed in, we eliminated by saying nobody can do, why would anybody do that? Let's go focus on those and quietly clean those up. Because the reality is most of those, some maybe, but most of those are financially related nuisance impacting the carrier, not safety related. We always have to, the big difference in aviation is some of these things that you do, the consequence could be injury or death. Most hacking is not going to relate, if it's financial or IP, it's not going to relate to injury and death unless it's a nation state preparing for a wartime, which could be that, but that's
Right.
that's prep and that's stuff that's, if it's happening, you probably don't even know it's taking place on your system because they're gathering information. That's the IP thing, to find vulnerabilities so you flip a switch in time of war, and we're doing the same thing. But to get down to, there's this balance between understanding but also saying, let's make sure, because the problem we have is perception a lot of time. If you can't protect your in-flight entertainment system, how can you not protect your flight control system? It's like, well, that's backwards logic, but that leads to people around aviation in general, around feeling unsafe if there's, do I want to fly if somebody could hack an airplane or take control of it on their Android? And, our immediate reaction in FAAs and others is, no, that can't happen. But there are other things behind that are like, yeah, we need to look at some other things there that may not be safety, but could cause an airline to not be able to fly the airplane or cause other things to happen, in which case we want to go fix those.
I want to comment that I'm sensitive to what you're saying, Mike, because the initial forays of the cybersecurity community into aviation may have been uneducated attempts, and it turns engineers who truly understand how the airplane works off. So some of the things that Remy's saying, he's a two-day wonder, and he knows it.
No, I'm not picking on Remy.
No, I know you're not. But I mean, this is an example, because there could be people that understand the systems that he was talking about, and they have a very visceral reaction that, hey, wait a minute, that's not possible. And they're probably right, but this is my concern. The very fact that the white hats are interested and pursuing this bother me, because the problem is there isn't any system that isn't vulnerable ultimately and can't be broken. It's a matter of effort and resources. And so I'm telling you, it's a red flag in front of the bull, like Dan's talking about, and it's only going to encourage more investigation. I mean, Remy's a good guy, but you heard him say, I'm really fascinated by this. There's lots of folks out there that are just totally fascinated. They'll spend their waking hours pursuing how we're gonna get in there. So we're just seeing the very beginning of it, and that's the concern.
I think our time is up here. It's in deference to Wayne, so thank you very much for being here. What I wanted to do is to show you and have you see, not only in this room, but also up front here, there's a small community that are concentrating on cybersecurity, and within the aviation community, it's even smaller. And the thing is, we're growing. Otherwise, anybody wants to get into this field, you have 100% job security, 100% job security and beyond. So in essence, you're paid well. So anyway, I want to let you know the fact is I want to thank Dan Geer particularly and all those others up here.